Hello everyone, my name is Matthew Wilson and welcome to our registered to video, which will be our serial adder with a control variable. And basically I'll go ahead and dive into that, what it means to have the control over the circuit, how to build it, and I'll go ahead and show you guys some examples too. Today's going to be kind of a short video, but getting straight into it. First, I'd like to talk about our data path and control model. So as you can see here, there are 5 arrows with 2 main bases here, control and data path. And a data path and control model is summed up as a circuit where the input data gets processed into the output data. And this can be applied to any finite machine, but specifically in this example, not like our other examples that we've done in the past since they've had a pretty easy construction and view. These go for a little bit more confusing type of circuits. So starting off with the steps. So number 1, you're going to start with your input data here, which is pretty much what it sounds like. It's the beginning, it's the start, it's what you put in, which then we're going to be introducing our external signals. The external signals are what's coming from the outside and they're telling the data path what to do or how to control and behave a certain way. These control signals bridge the link between the control and data path. They kind of tell what the external signals want over into the data path for the input data to do its work to get to the output data. And vice versa, the status signals will send feedback back to control. So these two are the really nice, link and bridge between the two. And then finally, you arrive at your output data, which are just your final answer, your final product. And from there, it'll wait until its next input data entries are put in. And this runs in a cycle in a loop infinitely. And showing you guys pretty much what I mean, I will go ahead and jump into Logisim now. Okay, so within Logisim, this circuit at first can be quite confusing, and it is. Bottom line, it is quite confusing, but working through some needed and necessary components, we were able to construct this. Basically making use of counters, decoders, muxes, our serial add, which we've turned into just a simpler design. So basically, what I'm going to show you guys today is how this control circuit works. And how we're going to get started is first we're going to reset everything. So we're going to make sure that everything is reset, that we don't have anything going. Then we will begin by putting in our inputs. And today we'll be doing hexadecimal C with 7. Oops, I just moved that to an 8. Back to 7 real quick. So, to begin, we go to simulate, auto tick enabled, so we'll have that clock running. Once we have our necessary inputs in, we will go ahead and click our start switch, which will take 4 clock cycles in order to hit our first state of 0, 1, which is our load in state. So basically everything is loaded in now. All the numbers are ready, everything is ready to begin. And in order to begin and put us into our add state, we will turn the switch off, which will then move us to our add state and give us our final sum. So everything moves at 4 clock cycles, right? So if you see here, we have our count, 2, 3, and 4. So every clock cycles, the state will change. So I can go ahead and reset this. Wait for this timer to reset. Start. So now it's in its load in. It'll count to 4. And this will go ahead on the 4th clock cycle. Excuse me. it actually takes 8 clock cycles in order to actually move on to the next one, because you have 4 inputs for each binary number. So once this will reach its final sum, if we want to redo this again, so we can make this any number. We can make this 3 plus 2. Okay. So starting, we're going to reset everything, make sure both of our control states are at 0, 0, which they are, as we can see here as well. We're going to start this switch. It will begin to load. And from there, we will wait until the count will hit 8, which then it will then fall into its adding state. And from there, it will clock 4 clock cycles until our sum is produced. So it goes to its add on clock 8, 1, clock 2, clock 3, and then on clock 4, we will begin our sum of 5. And then I'm gonna go turn this off. And then just to let you guys see this in action, if we go ahead and redo the example of C plus 7, I would just like to make something clear. So we'll go ahead and let this run like normal. Let it clock to 8. Go to its add, 2, 3, and 4. So I'm going to go ahead and turn this off. Although it doesn't matter, we can leave it running if we would like. We'll still keep the same thing. So our sum is in hexadecimal, so this does not actually read 13. So since our circuit is in hexadecimal, this output is in hexadecimal, this 1 actually carries a weight of 16. So it's 16 plus that 3 is 19, which will give you the C plus 7. Just to clear some things up. And that is all I have for you guys today. Thank you.